Okay, so we're going to start with our double angle formulae. So that means 2a, sine 2a, cos 2a, tan 2a. Okay, so they're all down here on page 14 of your log tables, but we're just going to have a quick look. Where did they come from? Okay, so for sine of 2a, you're basically saying that's sine of a plus a. And sine of a plus a, which we've already proven, is sine a cos b, so in our case another a, plus cos a sine a. Alright, sine a cos a plus cos a sine a, that's actually the same. So that's 2 sine a cos a. So that's the first one. Okay. Second one we're going to do is tan. So that's tan of a plus a. That's quite like the homework we just did. Okay, so you're replacing in this formula anywhere you have tan b with a, because in this case it's a plus b, so your b is a. So tan of a plus tan of a over 1 minus tan a tan a. Okay, so that's tan a and tan a is 2 tan a over 1 minus tan a by tan a is tan squared a. Okay, so that's where your tan of 2a formula comes from. And now we're going to do cos of 2a. So that's cos of a plus a. So go to your cos of a plus b formula and replace b with an a. So that's cos a minus sine a sine a. So this is cos squared a minus sine squared a. Now, that one is actually really useful, because if ever you have a cos squared a in your question, you can now replace it, okay, or a sine squared a. So we're just going to rearrange this. Cos of 2a is cos squared a minus sine squared a. Okay, now cos of 2a is, now do you remember what cos squared a is, or another way I can write cos squared a? If you go back to this page here, page 13 in your log tables, you've got this really important. Yeah, excellent. Cos squared a plus sine squared a is 1. So if my question all has sines in it, then I'm going to replace the cos squared a with 1 minus sine squared a. Okay, so that cos squared a, I just bring the sine squared a over and it becomes a minus. So I'm replacing that with that. So what I'm left with is cos of 2a is 1 minus, and how many sine squared a's do you have? You have 2 of them. So that's really handy if in the question they only want you working with sines and sine squareds. You can replace cos of 2a with this. Okay? And similar to that, if they only have cos and cos squareds in the question, you can replace the sine squared a. So number 5, start again with the same. Just go back, cos squared a plus sine squared a is 1. Just remember that, okay? If I want to replace this sine squared a, what you're going to do, bring that cos squared a over. So you get cos of 2a is cos squared a. Now instead of minus sine squared a, you get minus 1 minus cos squared a. So cos of 2a is cos squared a minus 1, minus by minus is plus cos squared a. So cos of 2a is 2 cos squared a minus 1. You have a cos squared a and a cos squared a, so that's 2 cos squared a. So these are important depending on what's given to you in the question. Okay, if you're interested in dealing with sines and sine squareds, you're going to replace this. If you're interested in dealing with causes and cos squareds, you're going to use this. Okay, so it is just kind of trial and error really in the question and seeing, okay, what else can I do? Now, they're not given to you, like this isn't given to you in your log tables. Okay, so I would think you should learn this. Okay, these are something you should know. Okay, you don't have to prove it or anything like that, but just remember it's not given to you, so you will have to either just learn it off or be aware that you're using this to get these. Now, the next thing is I can actually keep going from these and I can get, if I have what sine squared a is in a question, I can replace it with something else. Okay, so it's basically just manipulating these. So number 6 and number 7 carry on from these two. Okay, so number 6, cos of 2a is 1 minus 2 sine squared a. If I have this, okay, excuse me, I can rearrange it to get sine squared a on its own. So 2 sine squared a is 1 minus cos of 2a. Just rearranging these to bring the sine squared a to the left. And then to get sine squared a on its own, I just half this. Okay, so we're doing double angles and half angles. And you just leave it written like that. Now, that is given to you in your log tables down here. Okay, so this is your half angle, sine squared a is a half. That's where it comes from. You're just rearranging this one. And you can do the same with this one, rearrange this. So if I want to get the cos squared a on its own, it's cos of 2a minus 1 comes over, becomes plus 1. And then I have 2 cos squared a, and I just want cos squared a, so I just multiply this side by a half. Okay, normally we'd say we bring that 2 underneath the whole thing. That's the exact same as multiplying by a half. Okay, and that one is given to you as well there. Cos squared a is a half, 1 plus cos of 2a. Okay, now let's do a few examples of what they can ask. Can I get rid of the board? Okay, express sine of 3a in terms of sine a. In terms of sine a means you just want sine a. It's like saying in terms of x. You can't have any other letters. Okay, so in terms of sine a means you need to just have sine and a. Okay, so sine 3a would be sine of 2a plus a. Okay, now we know compound angles, we can just go here, sine of a plus b. Okay, so that is sine a cos B plus cos A sine B. Anywhere I have A, I'm replacing it with 2A. Anywhere I have B, I'm replacing it with A. Okay, so you're just using that formula, sine of A plus B. Okay, so I have sine 2A cos A plus cos 2A sine A. Now, I'm actually only interested in sine. Okay, so sine 2A is no good to me. It needs to be sine of A. So let's replace sine 2A with something. So go back in your example and see what sine 2A is. So that bit there is 2 sine A cos A by cos A. Okay, so that bit there was that bit there. And there's your cos A. Okay, you're also going to replace cos of 2A. Now you've lots of options for cos of 2A. I really only want the one that's going to have sine in it. Okay, so go and have a look for cos of 2A, and I know that this bit here is 1 minus 2 sine squared A. Okay, remember sine squared A is just sine of A to be squared, so that's allowed. Okay, by sine A. Okay, so what we did there was we replaced the sine 2A, okay, and we replaced the cos 2A, and we picked the formula that was going to have just sines in it. So what I'm left with here is 2 sine A cos squared A. Okay, and here I have sine A by 1 and sine A by minus 2 sine squared. So this is just multiplying brackets, okay, sine A by 1 is sine A, and sine A by minus 2 sine squared A is minus 2 sine cubed A. Is everyone okay with that? Now, I still have a cos squared A in my question, and I need that gone because I need it to be sines, okay? So we know cos squared A. I'm going to replace that coming back here. Cos squared A plus sine squared A is 1. So cos squared A is 1 minus sine squared A. Okay, here's what I'm replacing. Nothing happening over there because they're all sines, so I'm grand. So now I'm going to multiply this by this and this by this, okay? So 2 sine A by 1 is just 2 sine A, and 2 sine A by minus sine squared A is minus 2. Sine A by sine squared A is sine cubed A. And all you're going to do is gather, okay? So I have 2 sine A plus sine A. That's 3 sine A. And I have minus 2 sine cubed A minus 2 sine cubed A. That's minus 4 sine cubed A. So now I've expressed sine of 3A in terms of sine A. Any issues with that? Okay. Let's do example 2. Okay, so slightly different to what we've been doing. Given that theta is acute and that tan theta is a half, evaluate sine of 2 theta and cos of 2 theta. Now, they've told me tan of theta is a half. Straight away, go back to your junior cert. Draw yourself a right angle triangle. There's theta. Tan is opposite over adjacent. Opposite over adjacent. Okay, and you're going to be able to find out what x is. So x squared is 1 squared plus 2 squared. So x is 1 plus 4, 5. X is the square root of 5. Okay, now from that triangle, I'm going to be able to find sine of theta and cos of theta. Okay, now the question is sine of 2 theta. So we need to change sine of 2 theta. We need to pick a formula for it that's going to allow us to use sine, cos and tan of theta. So this one here, 2 sine A cos A. So 2 sine theta cos theta. Now, sine of theta is opposite over hypotenuse, 1 over root 5. And cos of theta is adjacent over hypotenuse. Okay, so you're just going to multiply all the top, so that's 4. And root 5 by root 5 is just 5. Okay, so that's sine of 2 theta. Now cos of 2 theta is the second. So let's have a look for a formula. The only one I can really use is the cos squared A minus sine squared A. Okay, that's just cos theta to be squared minus sine theta to be squared, so that's fine. I couldn't use these ones down here because it's cos of 2 theta. I don't have what cos of 2 theta is, I just have what cos of theta is. Okay, so cos of 2 theta is cos squared theta minus sine squared theta. So that's cos theta to be squared. So 2 over root 5 to be squared. And sine theta to be squared. 1 over root 5 to be squared. Okay, you're just going to throw it into your calculator. And you get 3 over 5. Okay, and I might just do one other quick one. Any issues with that? No. Great. Example 3. Okay, so cos of 2 theta is 7 over 25. Find the values of sine theta. So basically I need to have sine theta in my question equal to 7 over 25. So let's replace cos 2 theta equals 7 over 25. Now instead of cos of 2 theta, we need to replace that with one of the ones that we wrote into our box. So we had cos of 2 theta equal to 1 minus 2 sine squared theta. Okay, so that's not one that's in my log tables. It's this one, but I've just, instead of the cos squared A, I've replaced that with 1 minus sine squared A. So that's where that comes from. Okay, so you're going to put that equal to 7 over 25. Okay, then you're going to rearrange it. Okay, so that one comes over, becomes a minus. Minus 2 sine squared theta is 18 over 25. Am I right with that? now 7 over 25 minus 1 minus 18 over 25. Okay, then to get sine squared theta, I'm going to divide by minus 2. So I get 9 over 25. That's what sine squared theta is. Okay? So to get what sine of theta, that's basically sine theta to be squared. Don't forget that. Sine theta to be squared. Okay? So to get what sine of theta is, I need to get the square root. But remember, when you're getting the square root, you need the plus and the minus. Okay? So sine of theta is plus or minus square root of 9 is 3, square root of 25 is 5. Any issues with that? So it's just rearranging your formulae really.